We shall begin. All right. Well, I hope you guys are all doing well. Um, and let's go ahead and take a look. So today I want to kind of just introduce a little bit of, I guess, SQL or SQL. And so SQL is a very commonly used in industry, and it's a database system. And there's different kind of like flavors and varieties of SQL. You have MySQL and Postgres, and all kinds of different. And each of them have their own little kind of quirks and things that are will vary a little bit from one place to another. But they also have a lot of kind of common things, and so we'll kind of focus on the basics here. And certainly, um, so with SQL, it's fairly easy to learn the basics. Okay, it's fairly easy to learn the basics, and that's what we're going to try to cover in today's lecture. And certainly, you can learn a lot more and become, an expert. I would not consider myself anywhere near an expert, where you're kind of considering the efficiency of the different queries and the different requests that you make and whatnot. Um, here's an important note, okay, is don't try to set up your own SQL server, okay? There's a very big difference between setting up a SQL server and learning how to write queries, okay? It's like the difference between creating Google and just running a Google search, okay? Obviously, it's a lot easier to do a Google search, and that is a skill that you need to develop is, how do you find things on the internet reasonably quickly, but there's also a very big difference between learning how to write a few queries in SQL and setting up your own SQL server. So setting up a SQL server would probably require a class on databases and database, administration and things like that. And that's not what we're gonna go for today. Okay, so we're not gonna learn how to set up a server or how to design a database. Most likely, if you go work and your company that you work for says, "Hey, we have a SQL server and they need somebody who can deal with SQL," they're talking about somebody who they need somebody who can write queries. Whereas the person who's going to set up and design and maintain the server, that will specifically be the job of database administrator. And unless you're applying for that job, you don't need to know how to set up a database. Um, there are a bunch of places on the internet where you can learn SQL. You can just type in SQL tutorial into your search engine. Here's a couple resources. Unfortunately, these are free resources that are, clogged down with ads, but I guess that's the cost of being free. Okay, here, let me clear all of these outputs and we'll restart. So, with Python, you might need to do pip install SQL Alchemy. Okay, this is going to be a, I guess, a bit of software that allows us to interact with SQL databases. Okay, so you might need to do pip install SQL Alchemy. So that's going to allow us to kind of connect to databases and interact with them from Python. Um, and I'm going to use a data set called the Chinook SQLite dataset. Um, and SQLite is kind of like a standalone, all, packaged in one thing that allows you to kind of run SQL queries and you don't need to install extra software other than SQL Alchemy. Okay, let's go ahead and get going. We'll load up pandas, and then we'll load up SQL Alchemy. And really, we just need to import the create engine command. And we are going to connect to SQLite.SQLite. So this is a file. I've uploaded it to GitHub. So if you do git pull, upstream main, it should download this thing. And so we're going to create an engine here, and that's going to connect. And all right, and so let's just inspect it. All right, so we do have to import the inspect function. And this just to kind of check and make sure everything worked. I'm going to get the table of names and I'm going to print those out, and it looks like it worked because this is not blank. If you get back something and it's blank here, then that means you did not import this create engine correctly. Okay, so you didn't connect to this database correctly, but we have connected to the database correctly here. And so it says that we've got album, artist, customer, employee, genre, invoice line. This is an older database. Um, this is kind of, I don't know, dated from the late the late 20 aughts. So I don't know. You might have been like 5 years old. Um, in like 2008, 2009, um, I don't know if Spotify was a thing. I don't think it really was. And the way you would get music is you would go to, like the iTunes music store and you would buy individual tracks. So you'd say like, "Oh, I don't know what was popular in 2008, but you'd say, "Oh, I like that song and I want to download that song." And you'd pay like 99 cents per song or $1.29 per song. And or you could buy the entire album for $10 or something, and you would um these download your music that way. Now everybody just buys a subscription and pays, I don't know, $10 a month or whatever. And you just stream all the music that you want. But you go back 16 years or so, and you had to download and buy these songs individually. I don't know if you're familiar with such a setup. But anyway, this database kind of harkens back to that time period. And so the database has information about different albums, informations about the different musical artists, the track lists, and things like that. But then it also has information about, you know, um, purchases, invoices. So like what songs did somebody buy? And who was the customer that bought those things and so on and so forth. Okay. So that's kind of the background and the premise for this data set. Um, okay, so let's just do some very, very basic things, okay? So SQL in general is not case sensitive, okay? But the convention, all right? So it's not case sensitive in that you won't run into errors if you don't follow the convention. But people will complain that you have like, I guess, bad writing habits if you don't follow the convention, okay? So the convention is, um, I mean, it'd be kind of like writing something without using capitalization or without using spaces or commas, and people will kind of be able to understand what you've written, but if you don't follow the proper conventions, they'll say like, it's hard to read what you've written. Okay. So anyway, the kind of most basics is like I want to select these columns. Okay. You select variables from a given table. If you want to select all the columns, you use star. And then from is like I want to select it from this particular table. You specify which table you want to look at. Okay. So here, we're going to send our kind of commands in as text. And so the command here is that I'm this SQL command I'm going to do is called select star from album. I'm going to select all the columns from the album table. That's basically it. Now there's a whole bunch of stuff that like this is kind of the manual way to do it, and there's a whole bunch of steps here. And there's I'll show you a much easier way, but this is kind of the manual way is first you have to establish a connection to the engine, okay? Okay. And remember the engine, we created the engine by specifying this database. Okay. So here's our database, and that's our engine. And then we're going to say, I want to connect to that database. Okay. And then I want to um, I want to execute this SQL command, which is going to be select everything from the album table. Okay, we're going to execute with to our from our connection, and that's going to kind of um, our results is I stored at rs, and then I want to take those results. I'm going to call fetch all. I'm going to fetch all of the results and store them into a data frame. Then I close the connection, and then now I want to just kind of print the first few lines of the resulting data frame, and I also want to print just kind of the keys from my results. So this is kind of a lot here. Um, but it works in that I've connected to the database. I've selected all the columns. There's only three columns: album ID, title, artist ID, and then here are just the first 10 rows from that thing. Okay, and so these are some album titles, and these are these are like classic rock titles. So for those about to rock, we salute you. That's let me just pull that up here. I think that's from, I want to say AC/DC. Why is this not working? Copy, copy, and paste. Yeah, so that's 1981 album from AC/DC. I don't know if you guys even know who these people are, but this is like a classic rock band. Okay. Um, so then uh, you can kind of make this a little bit easier by doing using with. And so this time I'm going to say, hey, from the employee table, I'm going to select first name, last name, and title. I want to select these three columns from the employee table. I'm going to um, work the create just a string, okay? And I use triple quotes to kind of create my multiple line string, and then I can just do and then I can use a with thing, and I'm going to say connect with engine.connect as a connection. We're going to execute that command as text. Then we retrieve all of the, fetch all of those results. And then we will create our data frame out of that. And then we're going to take our keys and assign them to our column names. All right. And I can do that. And so here are the rows from our employee table. We have Andrew Adams, first name, last name, and then their title, so on and so forth. Um, this is what we have. Okay. The easiest way is if you do have a command, the easiest way is that Pandas has a function called read SQL query. Okay. Read a SQL query. And so all you need to do is you take this command that you've written, you wrap it in the text function here. Okay. You create a connection to the engine, and then you call read SQL query, you provide the query and then the connection, and then Pandas will automatically do all of this. So this is just kind of this, Pandas makes our life really easy by allowing us to kind of get all of these records from a Pandas data frame. I mean, from a SQL database and creating a Pandas data frame out of it. So there you go. So you get the same and exact thing. So this is the form I'm going to use here as far as executing SQL queries. Okay, so as far as executing SQL queries, I'm going to just write the command out here, and then I'm going to basically just use this same little chunk of code here. All right, so that covers just select from, and that basically selects columns from a table. All right, let me give you your first view quiz answer. First view quiz answer today is the letter C. So that's in the chat. First view quiz answer is the letter C, C as in cat. Okay. Um, so kind of the next command to learn is order, and that's going to just arrange. Okay. Oh, I don't have the quiz published. Let me see. Oh, you are right. You are correct. Okay. Sorry about that. Here we go. First answer is the letter C. Okay. All right. Uh, so here we're gonna order. I'm gonna select all the columns from the employee table. We're gonna order by birth date in descending order. Okay. So this is my command, and I'm just gonna do pandas read SQL query. So again, once you have your connection established, it's really simple with pandas. Okay, you don't have to do all of this business of opening the connection, execute the thing, fetch the results. Just just do it like this, okay? All right, so here we go. This is our information, and we say, oh, you know what? Our employees are all from Canada, and at imaginary company here, and our employees are old. Okay, so the youngest person is born 1973, and the oldest person is born 1947, which um, I don't know how old that is. That's pretty old, right? Uh, that's 77 years old. Okay. Um, so that's what we have here. But again, this is a older data set where you know, we're buying individual track titles from some imaginary music store here. Okay, but there you have it. Okay, so you can order by if you don't put in descending, I think it will put it in ascending order. So the default would be ascending, or you could specify ascending, or you could order by descending. Um, You can order by multiple columns. Let me see. Order by, let's see, last name. I don't have any. Is there anything? Okay, I guess so we'll order by city. So that and then let me see. So we can order by city ascending and then birth date descending. Okay, as a tiebreaker, right? So you can kind of order by one thing and then if you want both of these things ascending, so city ascending and then birth date ascending, however you want to do it, right? So you can specify multiple, um, multiple columns this way. All right, so that's how you go. The where is to kind of create these like filters, okay? It's like using an uh if Boolean mask here. So so here I could say, hey, I only want the people if their title is IT staff. Okay. If their title is IT staff. So I really only want these two people. Okay. Title is IT. So we're going to do select everything from the employee table where, so you can do stuff like where employee ID is greater than 6. Okay. Greater than or equal to 6. And so we're going to get employee IDs 6, 7, and 8. And that gives me IT manager, IT staff, IT staff. I could do and title is IT staff, and that just gives me this. You could specify whatever you want, right? So you can say where um, I don't know, but you can kind of um, specify things that way, right? And then you could provide. So we're just kind of making our query longer and longer by including more and more SQL things. Um, You have join, you have limit. Okay, limit returns just kind of like the first entries. So sometimes um you have a huge database, right? With like millions of entries. And if you say select everything, select star from album or, from the table, it might return, millions of entries. And that could be very inefficient. You might upset the the database administrator because they're going to be like, "Why are you putting in so many requests to the SQL Server? You're going to be tying up resources and things like that." So sometimes you just want to check and make sure your query is running kind of properly in the first place, without pulling everything. So you can just say limit 10. Okay, and this is kind of like calling head, on a data frame. You just say like, I just want to see the first 10 rows or something like that. Okay, so you can say, hey, select from the album table just like the first 10 things, and we get, again, our album titles. For those about to rock, we salute you, balls to the wall, restless and wild, let there be rock, things like that. Okay. And then I could say, hey, you know what? I want to just select the first few entries from the artists table. Okay. And the artist table, we have musical artists like AC/DC and Accept and Aerosmith and Alanis Morissette and things like that, right? So these are different things, and you could see how these tables link up. All right. So we have, you know, over here we have album ID, title, and artist ID. And artist ID is one. And so we go to the artist table and we say, oh, okay, for those about to rock, we salute you is by artist one. Artist one is AC/DC. Okay. Balls to the wall is by artist two. And that artist is Accept. Okay. Restless and Wild is artist two. Accept. Let There Be Rock is artist one. So AC/DC. Big Ones is from artist three. Aerosmith, so on and so forth. Okay. And you might wonder, like, why don't, isn't it easier for us to just put in AC/DC and then accept AC/DC, Aerosmith, so on and so forth? And certainly the answer, yes, it would be easier to read that way. But from a database standpoint, there's kind of a design principle where you want to minimize any kind of redundant information. Okay. And, here we've written AC/DC as AC/DC. And I think that's the official way we write AC/DC. But you might see, let's see, you might see AC/DC written, I don't know, without the slash, right? So you might see AC/DC just written like this. And I don't know. Okay. Um, there might not be a slash. There might be some places might write a dash or something like that. Okay. And and so you know, what if somebody, as they're entering, they wrote AC/DC for this entry, but then they wrote AC-DC for this entry? That is going to, when you do a filter and you say, hey, find all of the albums written by AC/DC, that is going to cause mismatches. Okay. And so it's better to just have one way to write their name, and then you avoid kind of having different spellings, different capitalizations, different kinds of things there. Okay. But when you have your information in different tables, you have to join them back together, and we'll join them back together using a join. Okay. So a join table or a join call takes two different tables and joins them together using, by matching up the columns here. So here I'm going to say select everything from the album table, but then join, and we're going to call an inner join. Inner join is only going to return entries that um, exist in both tables, okay? And we're going to join the artist to the album table. So from the album table joined to the artist table. And how do we join those things? We're going to look up artist ID in the album table. So that's done by doing album.artistid. And we want to find matches with the artist ID in the artist table. Artist.artistid there. And then we're just going to ask for just kind of the first 10 back. And so there we go. We get exactly what we expected. All right. For those about to rock, we salute you. Artist ID from the album table matches artist ID from the artist table, and we get back AC/DC, balls to the wall, except Restless and Wild is number 2, except Let There Be Rock, AC/DC, so on and so forth. So all of that information is matches up correctly here. Okay. Um, Now we might want to kind of change the title names, and we can do that. And so, and we might only be interested. Maybe we don't want these columns, album ID and artist ID, and stuff like that. So instead of doing select everything, I'm going to do select title and name. Okay, but the title we're going to call the album title, and then the name we'll call artist name, and we're going to use as. So we're going to say select title as album title, name as artist name, and then this part is the same as before. We join the album and the artist table from album interjoined with the artist table. And we do it on artist ID in the album table has to match artist ID in the artist table. Okay, so I do that. And this is kind of just like a cleaned up version of this. We don't have the album ID, artist ID, and artist ID tables columns there. We just have these things. Okay. Um, so that's how we do that. Okay, so that gets you, I think, pretty far. There's even more that you can do with SQL. So you can starting to do what do you call it? Summary values, and you can call group by and summary functions like count and sum and average. Okay, average will give you the mean here. So here I'm gonna do we want to select the artist ID and the name. Okay. Well, here let me start with this line here. From album joined with artist. Okay, where artist ID is equal there. So basically this table here. What I want to do is I want to count how many albums each artist has. So I'm going to then group by artist ID. Okay. And then we're going to select the artist ID, the name of the artist, and then I'm going to perform these summary functions. We're going to count how many albums we have. Okay. Now, this is a completely stupid thing to do, doing average and sum. Okay. Because album IDs don't have numeric things. So it is dumb to do here. But I just want to show you that these functions exist. Okay. So for AC/DC, we have 2 albums in our table. Okay. We have this one, For Those About to Rock, We Salute You, and Let There Be Rock as these things. And their album IDs were album 4 and album 1. So the album count is 2, and then the average ID of 1 and 4 is 2.5. And then if you sum 1 and 4, you get 5. Again, not meaningful because it doesn't make sense to add an average ID numbers. Okay. Similarly with Accept, their album IDs were album 2 and album 3. And so, their average album ID is 2.5 and their sum is 5. Aerosmith just had 1. Um, Antonio Carlos Jobim had 2 albums and apparently they add up to 42 or whatever. Okay, Audioslave has 3 albums, and their average is 97.33. They added up to 292 or whatever. Again, kind of silly to do when you're dealing with album IDs, but that's, you know, it's something that can be done by using average or sum, and then I renamed them as something here. Oh, by convention, we want to do capital AS for as. Okay. Let me give you your next view quiz answer, which is the letter D. D as in dog. D as in dog. Okay. Okay, so here is just, you can just kind of see, like, we grouped them by artist ID, and then we matched up there. So here I sorted by artist ID. And so you could see, yeah, you know what? When we had Audioslave, they had their album IDs were 10, 11, and 271. And that's why it added up to 292. Okay. Um, if you wanted to, you can also filter this, right? So you could say, after you group by. Now, now here's the thing. When you filter on the original individual rows in the table, you use something like where. Okay, so we say like where employee ID is this, or where album or whatever, where artist ID is that. Um, if you wanted to do something on the summary values, then the keyword you use here is album. Okay, so here I have the same kind of entry. I say select artist ID and name and the count as the album count from the album joined here, group by artist ID. But now I want to get only the rows that have album count greater than 8. So I call that, and these are the people in my data set, or the artists in my data set. Led Zeppelin has 14 albums, Metallica has 10, and so on and so forth. This is what we have. Who has how many albums? I don't know. Has number of studio albums by Led Zeppelin. 8 studio albums plus the posthumous ninth. I don't know. Number, how many? Maybe they have a bunch of compilation albums. I don't know. 9 studio albums, 4 live albums, and 10 compilation albums. Okay. Well, I don't know then. All right. Most number of albums by one artist. Nana Mouskouri, a Greek songstress. She sold, no. Released the most. She's made 450 albums? Whoa, okay. Most prolific musician. Okay. All right, well, I don't know. All right, I don't know who has a bunch of albums here. Buckethead. Buckethead has 204 albums. Johnny Cash, 167 albums. Okay. Well, that's a lot of albums. But anyway, this is just our little table here. Okay. 14 albums by Led Zeppelin. Metallica has 10 albums, and so on and so forth. Now, you can do also mathematical operations, like if you wanted to, you could take artist ID and multiply it by 2. Now, this is completely silly to do here, but if it's numeric, you can do a numeric operation. And so here we go. I got artist ID multiplied by 2, and I'm going to call that the magic number, and that can do it. I think you can even let me just try. If I do artist ID and album ID, I think I can do that also. Oh, it didn't like it. It didn't like it. Oh, that's from the artist table. That's why. Okay, we have to do it from the album table. Ugh. Oh, wait. Okay. What is the album? Okay, from album, album ID, artist ID. Okay, maybe you can't do it. Oh, there's no name. There's no it's title. That's why. Okay, now it works. So you can do artist ID, album ID, and then the product of artist ID and the album ID. Again, a totally stupid thing to do, but for albums and artists. But if you needed to do it something where where it makes sense, where you have these two numeric columns and you wanted to calculate ratios or products or something like that, it can be done. Okay, so you can do these kinds of mathematical operations um, there as well. Okay. Yeah, let's see how much more we can get through. So here's just a few more things. I'm going to join up a bunch of tables together. Okay. So so we have the album table, we have the artist table. Okay. We also have the invoice table, which says customer ID ordered this, and this was their kind of total of their purchases, I guess. And then we can look at the invoice line items, and it looks like this order from Stuttgart, Germany, the person ordered two songs, okay? And it was, this song was 99 cents and that song was 99 cents. So their total was $1.96. And then invoice ID line two, this person bought four songs at 99 cents each for a total of 396 and so on and so forth, okay? Um, and then within the albums, we have tracks, okay? And so album, for those about to rock, we salute you. There was a track, and then I don't know, this song, album three. I guess there's only three tracks on it. I don't know. All right. But this is, Fast as a Shark, Restless and Wild, Princess of the Dawn. These are the different tracks you could buy, and this is how many bytes the song is and how much it costs and how long the song lasts and whatever. Okay, and then also information about the customers, right? This person's from Brazil and this person's from Stuttgart, Germany, and it has information about their address and contact information. Okay, so what if I wanted to join some of these things? Well, this is the customer table. Now, to make it easier for me to kind of do these things, normally the way you reference columns is you do table name dot column name. So it'll be like artist dot artist ID or something like that, album dot artist ID. Okay. Now, if you're like, oh, that's too much typing, you can kind of make your life a little bit easier, right? And so you can say, hey, I want to join the customer table and the invoice table, but we're going to give our customer table an alias. We're going to do customer as little c and invoice as little I. And so now instead of doing customer.customer ID and invoice.customer ID, I can do c.customer ID and I.customer ID. Okay. So I can do that, right? So we're going to do from customer joined on the invoice. This is how we'll do it. Okay. And then as far as the columns I want to select, I'm going to say I want to select the customer first name, customer last name, invoice ID, invoice date, and invoice billing country. And again, I'm using the aliases, C dot and I dot and so on and so forth. So this is what we're going to do. And then for here, I just want the customers from Brazil. Just an arbitrary choice. Okay, and so we got Luis Goncalves who ordered made 7 different orders. Okay. Eduardo Martins also made, I don't know, 7 orders or something. I don't know, 6 orders, something. And then Alexandre Roja ordered, stuff, right? And these are from Brazil. And we can say like, oh, what about the ones from Germany? Okay. And we have these people from Germany. Um, I don't know, Canada, Norway, Czech Republic. So we can look up, our different Canada. Okay. We have different entries from different people. And so this is our data set. This is an artificially generated data set. So, they're like for each customer ordered exactly 7 times or something. How many unique values you can call distinct? Okay, so I can say, hey, from the invoice table, let's look at the billing country. Okay, so because this is my invoice table, what's the billing country? We could see how many unique values we have. And we're going to say select distinct billing country. And it gives us our distinct entries here. So we have, 24 countries: Argentina, Hungary, Austria, so on and so forth. And then, if you want, you can do order by billing country. Did I do order? I always misspell things. This is the hardest thing. Order by, there's a space between them. Okay. That's the hardest thing in SQL is just remembering what these things are. Okay. Argentina, Australia, so on and so forth, right? So you can order these things. All right, what if you want to join multiple tables, right? Here I want to join 3 tables together. So I'm going to join the invoice table with the customer table. And one thing that you'll see is that the customer table has a support rep ID. So each customer is assigned to an employee. And I guess I don't have that here, but we've seen the employee table, and the support rep ID here matches with an employee ID number. Okay. So we can do that. We could say, hey, uh, where are we drawing our entries from? We're going to take our invoice table, join it with the customer table, and we join the invoice and the customer table using customer ID. And whatever that result is, okay, so now we have invoice joined with customer table. We also want to join that result with the employee table, okay? And the way we're going to join the employee table is we're going to match the employee ID in the employee table with the support rep ID from the customer table. So in the customer table, we're going to join with the support rep ID. So that's what we do here. Okay. And then I want to select employee first name, employee last name. I want to select all the columns from the invoice table, and we're going to order by the employee ID. And so now I have 412 rows, okay? But these are all from Jane Peacock, okay? Jane Peacock has these different customers, and these are their different kind of invoices, right? Or I could say, hey, I want everything from the customer table, okay? And, Jane Luis Goncalves is assigned to Jane Peacock and so on and so forth. But, we joined it with all of the invoice information. So this is all kind of seems duplicated here. But I could say, hey, I want everything from the invoice table as well. All right. Now we left out some of these columns here. But that's what we have. Okay. So same idea. We're gonna join the employee with the customers on the invoice table. we're going to just kind of pull some of the columns we want. Invoice ID, invoice total, employee first name, employee last name, customer first name, customer last name. And in order, because both of these things have for dot first name and dot last name, in order to kind of make it easier for us, we're going to call it employee first, employee last. And then we can, this is easier for us to read. So we have Steve Johnson's employee, took Lenny Kohler's from Germany order. And then Margaret Park has Bjorn and Dan from Belgium and so on and so forth. Okay. Um, okay. How many questions did I give you guys? Just one? All right, I'll go ahead and I'll give you answers 2 and 3. Answer 2 is D. Answer 3 is B. Okay. Question in the chat. Is the final exam Python only? Yes. Is the final exam free FRQ, free response questions and multiple choice? Yes. How would you prepare for the exam? Well, I don't know. I will have to. Yeah, I'm still working on writing it, so I'm sorry I don't have more information about the final. I'm going to spend the rest of this week writing your exam, and then I'll have a better idea of what it looks like. And that's what we have. Oh, what's the difference between join and inner join? Great question. So I won't all of these get to all of these things here, but here is you have left joins, inner joins, outer joins. It's kind of like imagine a Venn diagram and do we have it here? You have the intersection. Okay, so let's say you have these different entries here, okay? We have ID pirate ID 1234, pirate monkey ninja, spaghetti, and then we have another table ID 1234. And then the names are Rutabaga, Pirate, Darth Vader, Ninja. Okay, so we have Pirate and Ninja in common, but not all of these other ones. Okay. There's a question. Would it be possible to post a practice test to prepare for the exam? I don't think I have it in me to write the full exam and also a practice exam that is similar but distinct enough. So I don't have. I will tell you once I write it, I will try to give as much of description as I can that will be helpful. Um, but um, but yeah, that I'm not out to try to like trap and get you guys to like mess up. All right. I just want to kind of check like do you understand the stuff that we've covered? So it's but I'll try to give you a you're actually terrified. Well, I guess we did cover a lot, but I'll I will try to do my best to give a fair explanation. Okay, so anyway, this is inner join. When you say like, hey, we want to match the name with the name, you're gonna get the intersection. Okay, if you do a full outer join, then you get the union, which means you're gonna have non-matches. Okay, so you get everything from the left table plus everything in the right table and then you get, where you don't have a match, you have a null. Okay. And then you have the left, which gets everything over here, and then you get non-matches over here. And then, but you can also say like, hey, what if I just want the ones in A that don't exist there? Then you do a left outer join, but then you put a where on where the other table is null. Okay. And so on and so forth. All right. So these are just different examples. This is I think, a handy little um, thing there. Okay. Does an inner join keep what they have in common and left join keep what the data set you're joining? Okay. So the left join gives priority to the left table, which is basically the first one that you list, and finds matches in the other one. And the inner join only returns ones that are in common. Okay. Left join keeps the data set where you're joining, but puts NAs. Yeah. So if the left join, it will keep everything in the left table, and then it will find matches in the right table. And if it doesn't find a match, it will put in basically NAs for those ones. Yep. Okay, we will end here. I don't know. We'll see if we get to the other entries in here from SQL. You can kind of look at it on your own time. You can, DataCamp has a bunch of stuff on SQL as well. So if you're trying to make yourself a strong candidate in the job market, you can do that. All right, we will end there. Have a great Thanksgiving holiday. So no class for the rest of the week, and we'll see you next Monday, 1 week from today.